Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, and the same chapter, that is chapter number 12, that we have started in the yesterday's class. And so I am going to continue with the same chapter in the today's class also, that is a query processing. So let's start with the previous class session, what we have covered in the last class, then move to the today's topic or today's session, that is the beginning or next to the query processing. So let's start with the previous class session, what we have covered in the last class. In the last class, we have started with the chapter number 12, that is the query processing. So what is a query? How to process the query? That is, whenever I want to process any query, whenever I want to give any query, that is done by the, or that is processed by the database management, that is known as the query processing. That means generating the output from the activities, that is known as the query processing. So query processing includes various activities or range of activities that involved in extracting the data from the database. So whenever I extract any data from the database, that is whenever I perform any task to extract the data from the database, that is known as the query processing. That means processing the query, processing the data, or processing or doing the range of activities in extracting the data from a database. That is a query processing. Suppose if I give the command select department name salary from the table employee, that means I'm fetching the department name salary from the table employee, so the data will be available in the query processing. The activities includes translation of queries in high-level database languages into expressions that can be used at the physical level of the file system. That means what are the various activities that is included in the query processing? That includes the translation of the queries in high-level database languages into various expressions that is used at the physical level of the file system. A variety of query optimizing transformation and the actual evaluation of the queries, that is how to evaluate the queries or what are the various tasks that is used in the evaluation of the queries. Then there are three steps in the query of optimization or the query processing. One is the parsing and the translation. That is, first of all, the parsing can be done, then there will be a translation, then there will be optimization, then there will be a evaluation. That means first is the parsing and the translation, then there will be optimization, then there will be evaluation. So these are the three steps that will be taken out while processing the query or while process the query. That is a query processing methods or steps. That is a parsing and translation, then optimization, then evaluation. So before query processing can begin, the system first must translate the energy into the or query into the useful form. So first of all, the query must be translated into the or transferred into the multiple useful form that can be understood by the human beings. That is a we can say the understandable form that is well suited for the internal representation of a query. That is very useful for the extended, we can say, the relational algebra that is used. Therefore, the first action in the query processing is to translate into an internal form. That translation is known as the parsing. So whenever there will be a parsing, that means translation of the query into the relational algebra that will understandable by the human beings. This translation process is very similar to the work that is performed by the parcel of a compiler. So just like the compiler translate the high level language into the machine level language, in the same way in the query processing, the parcel translate the query into the human readable form. That is a query processing. This is the diagram that shows how to process the query. What are the various steps that is used in processing the queries? So first of all, there is a query, then there will be a parser and a translator, then there is a relational algebra expression, then there will be execution plan, execution engine, evaluation engine, then there will be a query output. So these are the various steps that will be used for the data processing. That is various steps in the query processing. This is one of the example that is given, that is select the salary from the table instructor where the salary is less than 75,000. This query can be translated in any of the relational algebra forms. So either we can use the selection, either we can use the projection. There will be I, there will be a sigma, there will be a pi, there will be a pi, there will be a sigma. Further, we can also execute each relational algebra that will be used, that will perform various algorithms. So to specify fully how to evaluate a query, we need not only to provide the relational algebra expression, but also to use the instruction that is specifying how to evaluate the query. So there will be a pi, that is a salary. There will be a sigma, that is a salary is less than 75,000, and the table is the instructor table. Then we have also talked about the query optimization, that is how to optimize the query, that is minimize the cost of the evaluation, that is the query optimization. So whenever I perform any query, whenever I put any query, whenever I give the command for the query and the cost is very low, that is known as the query optimization, that is optimize the query in a singular form. Once the query is chosen, the query is evaluated with that plan and the result of the query is output. So whatever the result that is given by the query, that is the output of that query. Then we have talked about the measures of the query cost, that is what are the various measures that is used in the query cost, that is the measures of the query cost. So there are multiple evaluation methods or the plans for a query, and it is important to compare the alternative in terms of their estimated cost. Choose the best plan, that is comparing the results, what are the various results, what are the various alternative that will be used for the evaluation of the queries, and what will be the values, what will be the cost that is given in the query optimization, that is a query evaluation plan. Therefore there will be a multiple algorithm, evaluation algorithm for each operation that will be used in the given timeline to examine the cost of the operation. So whatever the cost that will be used, that will examine the cost of the operation or cost of the query evaluation. That is what is the cost or how much time is required by the CPU, what is the cost required to execute the query. We use the number of block transfer from the disk and the number of disk seeks to estimate the cost of a query evaluation plan. So we will use the block transfer, we will use the number of disk seek that is used to estimate the cost of a query evaluation plan. If the disk subsystem takes an average of TT seconds to transfer a block of data and has an average block access time of T seconds, then the average time that will be used to transfer the query, that is query time, that will be taken out as a B into TT plus S into TT, TS, that is the B into TS and the B into TT plus S into TS seconds. So this is the measurement of the query that will be used for querying the process or for processing the query. The cost estimate that we give that does not include the cost of writing the final result of operation block on or back to the disk. That is, whatever the cost that is estimated for the query does not include that whenever we write the output to the disk that is available in the result. And whatever the response time that is used for a query evaluation plan, that is used for the activities, that is the whole clock time that is required to execute the plan, that is a response time. And it also depends on the buffer, that is how much time or how much the space of the buffer is required, that is the response time depends on the contents of the buffer when the query is executed. Then there will be a selection operation, that is a selection operation means how to select or what are the various operations that will be used to select the operation, that will be a selection operation. So in a query processing, the file scan is the lowest level operator to access the data. That is a file scan means whatever the file that is scanned, that is a scanning of the file, is the lowest level operator that is used to access the data. File scans are search algorithm that locates and retrieve records that fulfill a selection condition. So file scans are the we can say the search algorithm that is used for searching the things, that is used for searching the locations that locates and retrieve the records that fulfill a selection condition. In relational systems, a file scan allows an entire relation to be read in those cases where the relation is stored in a single dedicated file, that is the relation is obtained in a single dedicated file. Then how to select using the file scan and the indices. So what are the various methods that will be used to scan the files? There are multiple methods, multiple indices that is used. First is the A1, that is a linear search, that is a search that is used for linearly counting the or the in a sequence way counting the records, counting the search, or we can say the finding the records in a database systems. Then next is the A2, that is a primary index equality on the key, that is using the primary index that will use the equality, that will use the key that will be very equal on the database records, that will use the index that satisfies the corresponding equality condition. Then there will be a A3, that is a primary index, that is a equality on the known key. So A2 means the primary index, there will be equality on the key. Then A3 primary index, that is equality on the known key. This is the table that we have discussed, that is a linear search. This is the average case. This is the primary case, that is a B plus tree, secondary tree, that is the query processing details. Then selection using the involving the comparison, that is how the comparison operator will be used. This is the comparison operator that will be discussed. Then there will be a secondary index and also the comparison. Then we also talked about the complex sections, that is selection, that is how to make the complex selections. That includes the parts, that is a conjunction, that is a disjunction, that is a negation. So these are the three parts that is used. One is the conjunction, that is of the form this one. Then disjunction, that will be taken like a V. Then there will be a negation, that will take the negative sign. Now next is the sorting, that is how to sort the record, that is what are the various sorting algorithm that is used. This is the today's topic, that is what is the sorting and what are the what are the various advantages that is used by the sorting, and why we need the sorting, that is what is the requirement of the sorting methods. So let's start with the sorting also. So sorting plays an important role in the database system for two reasons. Why? First of all, SQL queries can specify that the output are to be sorted. That is a SQL query can specify, or with the use of SQL, we can specify that the output that is used or the output that is displayed is in sorted order, that is in the arranging order. This is one of the main reason why sorting is very essential. Then next is equally important for query processing. Several of relational operations such as joins can be implemented efficiently. So most of the relational operations that will be used, that such as the joins, can be implemented in an efficient way if the input relations are sorted, or in the input relations are first sorted. That is, if the query is in the sorted order that will be used, such as the join, that will be implemented in a sorted order. So we can easily join whenever there will be a data that will be in the sorted order. Therefore, we discuss sorting before discussing the join operation in this one. So there are two types that will be used, that is how to sort the algorithms. This is we have already discussed. Then there will be a join operations. Yeah, this is also discussed, that is how to join the operations. Yeah, nested loop join, that is also discussed in the last class. Then the block loop index, that is also discussed in the last class. Index, there will be merge join, this table, this also discussed. Then cost analysis is also discussed in the last class. Then hybrid join is also discussed in the last class. Then recursive partitioning is also discussed. Then handling of the overflow, that is also discussed in the last class. Then what is the cost of the hash join? There is a formula that is also discussed in the last class. Complex joins. And then other operations is also discussed, that is a duplicate set operations, outer join, aggregation. Now next is the evaluation of the expressions, that is how to evaluate the expression. That is this is the today's topic. Yeah, this is the today's topic. I'm sorry because we have discussed all the things in the last class. Now today's topic is evaluation of the expression, that is how to evaluate the various expression that is used in the database systems. So far we have studied how individual relational operations are carried out. Now we consider how to evaluate an expression that is containing multiple operations. That is, till now we discussed what are the various operations, what are the various relational operations that will be carried out for the given database. Now this is the time to carry out or to evaluate an expression that contains a multiple operations. The obvious way to evaluate an expression is simply to evaluate one operation at a time. That is, if I'm going to evaluate multiple operations, that means that will be used or that contains multiple expressions, but the main thing is that we have to evaluate the single expression at the same time. That is, only one operation is evaluated or solved at a one time in an appropriate order. The result of each evaluation is materialized in a temporary relation for subsequent use. So first of all, when the operation is performed on any one operation or any one criteria, then the output is materialized, or we can say that checked in a temporary relation for the subsequent use. A disadvantage to this approach is the need to construct the temporary relation. That is, what is the disadvantage of this one? So again and again times we have to evaluate, we have to check out, we have to construct the temporary relations that must be written into the disk. And the alternative approach that is used to evaluate several operations simultaneously in a pipeline. That is, not every relation will be used, or not each and every operation will be carried out in a separate temporary location, but we have to consider, we have to evaluate the several operations simultaneously. That is, at the same time, multiple evaluation can be performed in the at the same time, that is done in the pipelining, that with the results of the one operation passed to the next. That is, for example, one operation will be carried out, then the output of that operation will be carried out to the next operation, then the output is carried out to the next operation, and next. That means it is carried out to the next operation, next operation. So there are multiple operations that will be carried out in a pipelining, with the result of one operation that is passed to the next without the need to store a temporary location. In section 12.7.1, that is a materialization, and the 7.2, then that is a pipelining. So in both the topics we have chosen the technique, we have chosen how to get the, or how to use, or how to evaluate the multiple expressions at the same time. That is a materialization and the pipelining. We shall also see that the cost of these approaches can differ in a different way, but also that there are cases where only the materialization approach is feasible. That is, there are some criteria, there are some methods in which the materialization approach is very fruitful. That is the materialization approach. So the first part is materialization, that is how to use the materialization, what is the concept that is used in the materializations. So it is easier to understand, that is how to evaluate an expressions by looking at a pictorial representation of the expression in an operator tree. That is, we have drawn an operator tree that is used for the materialization. That is a pictorial representation of the expression in an operator tree. So consider the expression, that is a pi name, then there will be a sigma, building equals to Watson, department, then there will be a join, that is a instructor, that is a join department and the instructors are joined with each other in a relation as a table, and the building name is the Watson. So if we apply the materialization approach, we start from the lowest level operands or operations in the expression. That is, this is like a tree. That is, the first of all, the lower level operations are carried out, then the upper level, then the top level operation will be carried out. So it starts from the bottom and go to the top. That is a bottom up approach. So if we apply the materialization approach, we start from the lowest level operations in the expressions, that is at the bottom of the tree. In our example, there is only one such operation, that is a selection operation on a department. The inputs to the lowest level operations are relations in the database. So whatever the input that is given, that is available in the lowest level operation, that is the relations in the database. We execute these operations by the algorithms that we have studied earlier. That is, how to get, or how to make out, or how to use that expressions in the relation that is used in the current databases. This is the pi, this is the join, this is the building equals to Watson, then instructor, then department. So by repeating the process, we will eventually evaluate the operation at the root of the tree, giving the final result of the expression. So whenever we execute multiple operations, whenever we evaluate the operations, that starts from the root of the tree, that gives the final result of the expression. So it starts from the bottom level and go up to the root of the tree, that will give the final result of the expression. So evaluation is just described as a materialized evaluation, that is, how to evaluate the material, or how to evaluate the content in a materialized way. Since the result of each intermediate operations are carried out or created and then are used for the evaluation of the next level operation. That is, how to evaluate the criteria, how to evaluate the intermediate operation that will be carried out for the evaluation of the next level operations. And the cost of a materialized evaluation is not simply the sum of the cost of the operations, involved. So there will be cost that is used, that is depends on the expression that will be used, that is the cost of writing the intermediate results to the disk. Then next is the double buffering, that is used the two buffering with one continuing execution of the algorithm while the other is being written off. That allows the algorithm to execute more quickly by performing the CPU activity in the parallel. That is the CPU activity is going in the parallel activity with input output activity. And the number of seeks that can be reduced by allocating the extra blocks to the output buffer and writing out multiple blocks at once. That is the writing out the multiple block at one time, that is used in the multiple expressions. Then the next materialization is finished. Then the next one is pipelining. That is what is the pipelining and how to use the pipelining. So we can improve the query evaluation efficiency by reducing the number of temporary files that are produced. So in order to improve the query evaluation efficiency, that is we have to choose, or in order to efficient the query evaluation techniques, we have to reduce the number of temporary files that are produced. We achieve this reduction by combining several relational operations into a pipeline of operations. So to improve the query evaluation efficiency, we can achieve the query evaluation efficiency by reducing the number of temporary files that are produced. We achieve this reduction by combining several relational operations into a pipeline of operations. So whatever the operation that will be carried out, that will be carried out in a pipeline of operations, in which the results of one operation are passed to the next operation in the pipeline. That is, the result of one operation will be passed to the next operation, that will be passed to the next operation, and so on in the pipelining. Evaluation, as just described, is known as the pipeline evaluation. That means whenever the output of one is passed to the another one, then the output of next one is passed to the next one, and so on. That is known as the pipeline evaluation. For example, consider the expression. This is the expression that is used. If materialization were applied, evaluation would involve creating a temporary relation to hold the result of the line, then reading back in the result to perform the projection. So for example, consider the relation, consider the expression that will be carried out for the generating the records. So whenever we create the pipelining, that will be used. So creating a pipeline of operations can provide two benefits. So there are two benefits of providing the uh, evaluation, or of providing the pipelining. That is, there are two methods of operating the pipelining that will be used. So creating a pipelining can involve or can provide two benefits. So these are the two benefits of using the pipelining. That is the result of one which carry out to the another one, and so on to the next line. So what are the two benefits that is used? The first benefit is that it eliminates the cost of reading and writing temporary relations. So there is no need to write the output on a temporary location. So there is no requirement of the memory, there is no requirement of the space, that is, there is no requirement of the anything, because there is no temporary relation, there is no temporary file that will be used to read out the data, to write the result, because everything is used as an again and again for the result of the, or the for the input of the another one. So it eliminates the cost of reading and writing the temporary relations, reducing the cost of the query evaluation. So it reduces the cost of the evaluation technique, because whenever we use this one, whenever we apply this one, so this eliminates, or this removes the cost of the reading and writing temporary relations. Then next one is, it can start generating query results quickly if the root operator of a query execution plan is combined in the pipeline with its input. So it can start generating the result. It can start generating the query results quickly when the root operator of a query evaluation method is combined in the pipelining with the inputs. This can be quite useful if the results are displayed to the user as they are generated, since otherwise there may be a long delay before the user sees any query result. So that means the response time is very quick in case of the pipelining methods, in case of the pipelining queries. Now, how to implement the pipelining, that is our next topic. That is, what are the various techniques, what are the various methods to implement the pipelining. So we can implement a pipelining by constructing a single complex operation that combines the operations that constitutes the pipelining. Although this approach may be feasible for some frequently occurring situations, it is desirable in general to reuse the code for individual operations in the construction of a pipelining. So we can implement a pipelining, we can use a pipelining by using a single complex operation that combines the operation that constitutes a pipeline. There are multiple operations that will be used that combines the operation that are doing the operations for the single pipelining methods. Although this approach may be feasible for some frequently occurring situations, it is desirable in general to reuse the code for the individual operations, so that is, reuse again and again the same code in the construction of a pipelining. In the example of this one, all three operations can be placed in a pipelining. That is, in the figure 12.1, that is displayed, that will display the content of each pipelining method, that will display the content of three operations in a single pipelining. This is a 12.11, that is the three pipelining, that is 1, 2, 3. There are three blocks that will be used for the pipelining methods. All three operations can be placed in a pipelining, which passes the result of a selection to the join as they are generated. In turn, it passes the result of the join to the projection as they are generated. So there will be a first of all selection that will pass the result to the or that will pass the result to the join, then join pass the result to the projection or the selection. This is what is it said, that is it. First of all, there will be a selection that will pass the result, that is pass the result to the selection, that selection pass the result to the projection, that is a join operation that is used. The memory requirements are low since the result of an operation are not stored for the long activities. However, as a result of pipelining, the input to the operations are now available all at once for the processing. That is a input that is available, that is we can say the output input that is generated with the operations, that is resulting as a case of the pipelining, that is not available all at all for the processing. Now, what are the two methods or what are the two criteria in which the pipelining can be executed? So pipelines can be executed in either of the two ways. So what are the two ways? One is a demand driven pipeline, that is in a demand driven pipeline the system makes repeated requests for tuples from the operation at the top of the pipeline. That is, whenever there will be a demand, that the pipelining method will be used. That is a demand driven pipeline. And each time that an operation receives a request for the tuples, it computes the next tuple to be returned and then return that tuple. That is, automatically the tuples will be repeated, the tuples will be rotated at the content end. If the inputs of the operations are not pipelined, then the next tuple to be returned can be computed from the input relation. That is, if there is no pipeline for the next operation, then whatever the output, whatever the tuple that will be returned from the, that is computed from the input relations. The next is the producer driven pipelining. So one is on the basis of the demand, the pipeline method will be carried out. Then on the basis of the producer, that is whatever the producer produce, there will be the producer driven pipelining. In this, the operations do not wait for request to produce tuples, but instead generates the tuple very eagerly. That is, generate the tuple very quickly, very efficient method. Each operation in producer driven pipeline is modeled as a separate process or thread within the system. That is, every process is treated as a thread, every process is treated as a method that will be used for the different pipelining methods. And each operation can be implemented as an iterator that provides the following functions. These are the following functions that will be carried out in various operations, that will be going in the various operations. So each operation in a pipeline, demand-driven pipeline, can be implemented as a iterator that provides the following functions like open, next, close. So these are the following functions. After a call to the open, each call to the next returns the next output tuple of the operation. The implementation of the operation in turns call the open and the next function. So whenever we implement, there will be two functions that is called, that is the open and the next. That is no more required, and the iterator maintains the state of its execution in between calls so that the successive next request receives the successive results of the tuple. For example, for an iterator implementing the select operation using linear search, the open operation starts a file scan and the iterator state records the point to which the files has been scanned. And there is a producer driven pipeline that is implemented in a different manner that will be used for the pushing up laziness. There will be multiple methods. Then the evaluation algorithm for the pipelining, that is what are the various algorithms that will be used. So some of the operations such as sorting are required for the blocking operation, that is they may not be able to output any results until all the outputs or all the tuples from their input has been examined. So until all the rows are examined, that will be not carried out, that will be a blocking operations. Other operations such as the join are not inherently blocking because specific evaluation algorithms may be blocking. For example, whenever we use the hash join algorithm, that is a blocking operation, since it requires both its input to be fully retrieved and partitioned before the output are generated. So before the output are generated, it requires that the new approach will be carried out, new method will be carried out to the new operation. It is therefore said to be pipelined on its outer relation, that is the outer method, that is although it is blocking on its index input, that is the right hand input. This is one of the method, that is a double pipeline join algorithm. That is how to use the double pipeline join algorithm. Now next is the summary, that is the finished of this chapter. So in this chapter, very small chapter, that is the query processing, how to do the query processing, what are the various methods, how to evaluate the expression, that is divided into two parts, that is the materialization and the pipelining. So summary is the crux of the chapter, that is the first point. The first action that the system must perform on a query is to translate the query into its internal form. So whatever the first method that is used, that the system must perform on a query, that is to translate the query into the internal form, that is usually based on the relational algebra. So whatever the first function, whatever the first action that is required, that is to translate the query into the internal form, that is done by the parser, that is done by the translator. In the process of generating the internal form of the query, the parser checks the syntax of the user's query, verifies that the relation names appearing in the query are the names of the relation in the database. And if the queries are the query are expressed in terms of a view, the parser replaces all references to the view name with a relational algebra expression to compute the view. The next point, given a query, there are generally a variety of methods for computing the answer. So whenever we are giving the query, there are multiple answers, there are a variety of methods that are used for computing the answer. It is the responsibility of the query optimizer to transform the query as entered by the user into equivalent query that can be computed more efficiently. We can process simple selection operations by performing a linear scan. So there will be a linear scan that will be used, that is a simple operation that is used by using the method of the indices. Then we can also sort the relations. We can also use the sorting method for the external by using the external sort merge algorithms. And then queries also involve a natural join that may be processed in the several ways that depends on the availability of the indices and the form of physical storage of the relation. So it depends on the method to method, it depends on the join to join that can be processed in the several ways. Now what are the various operations that will be used? The first point says if the join result is almost as large as the Cartesian product of the two relations, a block nested loop join strategy must be the advantageous query. Then if indices are available, the index nested loop join can be used. And if the relations are sorted, a merge join can be feasible or desirable. Then hash join algorithm, the relation is divided into multiple pieces. Then duplicate elimination, projection, set operations, union, intersection, and the aggregation can be done by sorting or by the hashing. So there are two methods. Either we can use the sorting, either we can use the hashing to make the or to remove the duplication, to remove the set, to remove the projection. Then outer join operations can also be implemented by simple extensions of the join algorithm. Then hashing and the sorting are dual in the sense that any operation such as a duplicate elimination, projection, aggregation, join, and outer join that can be implemented by using the hashing method. Then any expression can be evaluated by the method of by the means of the materializations and the pipelining. And the materialization means the result of each expression is stored in a temporary file, that is a disk. And pipelining means the result of each expression must be stored in or must be used as an input for the another string, or can be used as a input for the next expression. So there will be no storage of the on the memory. Then there will be a review terms. These are the various review terms, that is the query processing, query evaluation plan, evaluation primitive, query execution engine, query execution plan. Then these are the practice exercises that is used. Then this is the bank database, that is the primary key, nested key that is used. Then index nested loop join operation that will be very efficient for the secondary indices. Then these are the various questions, exercises questions, bibliographic notes. Now next chapter is query optimization. So we are finished with the chapter query processing. That also includes the query optimization, that is optimize the query. That means including the low cost, including the less cost to run the query. That is use the less cost method to run the query. That is the query optimization. That is chapter number 13. So let's take a break right now. Then after the break, let's move to the next chapter, that is chapter number 13, that is the query optimization. Let's take a break right now. So come back after the break. Now let's start the session again. Now start with the chapter number 13, that is a query optimization. That is how to optimize the query, that is a query optimization. So there are various optimization techniques. So first of all, understand the meaning of the query optimization. That is performing the query with incurring less cost, that is known as a query optimization. That is optimizing the cost of the query so that it will be beneficial, it will be benefited by the terms and the condition that will be given in the query. That is a query optimization. So let's start with the query optimization introduction. So query optimization is a process of selecting the most efficient query evaluation plan from among the many strategies that is usually possible for processing a given query. So the query optimization means optimize a query. That is a process of selecting the most efficient query evaluation plan. That is performing or getting the most efficient query evaluation plan. So getting out the plan from among the many strategies that is available. So that will be used to get the plan, to get the strategies that is usually possible for processing a given query that is used if the query is complex. That is if there are multiple methods that is used for processing the queries. So choose out the best query method, choose out the best query evaluation plan among the different plans that is usually possible for processing a given query. So if there is a given query, that is a processing of the query that will take place. So taking out the best possible method, the best query optimization or the query evaluation plan that is used among the many strategies that is usually possible for processing a given query, especially if the query is complex. That means optimization means getting the best alternative out of the best option out of the available alternative. We do not expect users to write their queries so that they can be processed efficiently. Rather, we expect the system to construct a query evaluation plan that minimizes the cost of query processing. So it is not a manual query optimization. It is an automatic query optimization that minimizes the cost of the query evaluation. This is where query optimization comes into the play. One aspect of optimization occurs at the relational algebra level, where the system attempts to find an expression that is equivalent to the given expression. So one of the major aspects of the optimization that occurs at the relational algebra level, where the system attempts to find an expression that is used that is equivalent to the given expression, that is more efficient to execute. Another aspect is that selecting a detailed strategy for processing the query, such as choosing the algorithm to use for executing an operation, choosing the specific indices to use, and so on. So these are the various aspects that is used in the query optimization to optimize the query. That is, which is the best alternative that is used, what is the best method to execute, what are the various operations that is the best suited for execution, and choose the specific indices that is used for the query optimization. The difference in the cost, that is on the in terms of the evaluation time between the good strategy and the bad strategy, is often substantial and may be used order of the magnitude. So it is worthwhile for the system to spend a substantial amount of time on the selection of a good strategy for processing a query. So it is very beneficial for a system to spend a substantial amount of time or give a high amount of time on a selection of a good strategies for processing a query, even if the query is executed only once. So even if the query is executed only once, there will be a optimization technique, there will be a, we can say, the time will be taken or time will be given on optimizing the query, on getting the query. That is a that is the amount of time that is required for processing a query if the query is executed only once. Now, overview. Consider the following relational algebra expression for the query, that is, find the names of all the instructors in the music department together with the course title of all the courses that are the instructor teach. So getting out the department name, that is a music, from the instructor table, and and the teacher teaches the table with the course ID, that is a pi, that is a course ID, and the title. This is the pi, then there will be a name, then there will be a title, then there will be a sigma, then department name equals to music, that is the name of the department is music, then instructor, then that combines or joins the teaches, then also joins the pi, then course ID, title, then course. This is a query that takes or that gives the name of all the instructors in the music department together with the course title of all the courses that the instructor teach. So that will give the course title of all the courses that the instructor teach. Note that the projection of the course on the course title is required, since the course shares an attribute department name. That course ID and the title is required, that is also required for getting the query, since the course shows the query, since the course shows the attribute that department name with the instructors. And if you remove this attribute using the projection, that is the department name is distributed, the above expression using natural join will return only the courses from the music department, even if some music department instructor taught courses in other department. The above expression constructs a large intermediate relation, that is the instructor joins teaches joins by course ID title course. However, we are interested in only a few tuple, that is getting only the few tuple, not every tuple of the relation that is used. So this is the initial expression tree, this is the transformed expression tree, this is the pi, this is the pi, this is the sigma that is used, department name equals to music, then instructor, then teaches, then course, the name, then the department name equals to music, then instructor, then teaches, then course ID, title, and the course. That is used as a relation, that is used as the output of the relation, that is used in the one of the 10 attributes of the relation. So by reducing the number of tuples of the instructor relation that we need to access, we reduce the size of the intermediate results. Our query is now represented by the relational algebra expression. So this is a query that is represented by the relational algebra expression, that is pi, name, title, then sigma, then department name equals to music. So department name is the music, that is from the instructor table, that combines with the teaches table, that combines with the course table, and taking out the two attribute, that is a course ID and the title, from the table course, which is equivalent to the original algebra expression that is used, but which generates small intermediate relation, that is it combines the two relation, it combines the two forms that will be used for generating the record. So evaluation plan defines exactly what algorithm will be used or what method will be used for each operation, and how the execution of the operation should be coordinated. That is, what are the various algorithms that will be used, what are the various methods that will be used for the execution for the operations, and what are the various techniques that will be used in the various expressions. So given a relational algebra expression, it is the job of the query optimizer to come up with the query evaluation plan that computes the same result as the given expression and is the least costly way of generating the record. So given a relational algebra expression, it is the responsibility of the query optimizer to come up with the query evaluation plan, that is how to evaluate the query optimization plan that computes the same result as a given expression, that is the same result will be carried out as a given expression that will give the least cost way of generating the result. So to find the least cost query evaluation plan, the optimizer needs to generate the alternative plans that produces the same result as a given expression and to choose the least costly one. That is, the least cost method will be used, or the least cost query optimization will be used. So the generation of the query evaluation plan involves three steps. What are the three steps? That is generating the expression that are logically equivalent to the given expression. So this is the evaluation plan. That is, first of all, pi, that is a sort to remove the duplicates, then pipeline, merge, sort, pi. These are the various methods that is denoting the various contents. What's your query, Larry? The relational algebra statement are the user defined statement. I mean, what is the type of what when we type the query, it is a build expression carried on. It is a inbuilt expression that is used. That is, a pi is inbuilt. This is the inbuilt, but we have to define this by its own, by our own. That means it is user defined and the pi is the predefined. This expression is predefined and this term is user defined. In the same way, there will be a pi that is used. In the same way, there will be a sigma that is used. So finally, the materialized view helps to speed up the processing of the certain queries that will be maintained for the query optimization. Now, viewing the query optimization or viewing the query evaluation plans, that is, what are the various methods, what are the various planning, what are the various terms that will be used for planning the query evaluation, that is, how to evaluate the query in a proper manner. So there will be a GUI, that is a graphical user interface, that is used to define the database with the various application or to view the evaluation plans. So it will use the command, that is a explain query, which displays the execution plan chosen for the specified query and the exact syntax that is varies with the different databases. So what is the exact sequence? That is a PostgreSQL uses the syntax shown above. Oracle uses a syntax, that is a explain plan for. So the PostgreSQL uses the explain query, then the Oracle uses the explain plan for, that is a different syntax that is used. Then DB2, that is a database 2, follows a simple approach to the Oracle but requires a program DB2 to be executed to display the stored plan. Then SQL Server, that will require the command, that is a set show plan text on. So the estimated cost for the plan are also displayed along with the plan. Then the next is transformation of the relational expression. That is how to transform the various methods of the relational expression. That is the transformation of the relational expressions. So a query can be expressed in several different ways. So there are multiple methods in which the query can be processed, query can be expressed with different cost of evaluation. So there are multiple cost of evaluation method that will be used. In this section, rather than take the relational expression as given, we consider the alternative query or alternative evaluation expression. So what are the various alternative evaluation expression that will be used to evaluate the query? Two relational expressions or relational algebra expressions are said to be equivalent. So when we talk about the two relational algebra expressions, that is equivalent if on every legal database instance the two expressions generate the same set of tuple. That is, on the legal instance, the two expressions that is given, when we say they are equal, that means they generate the same set of tuple. That is, the output that is generated that contains the same tuple, same rows as given by the two relational algebra operations. Recall that a large database system is the one that satisfies the integrity rules also. In SQL, the input and the output are multi-sets of the tuple and the multi-user version of the relational algebra. This is one of the methods. These are the various transformation rules. Now next is the equivalence rules. That is, what are the various equivalence rules? This says that the expressions of two forms are equivalent. We can replace any expression of the first form by the expression of the second form or vice versa. That is, the first form can be replaced by another form can be replaced by the first form. That is, we can replace an expression of the second form by an expression of the first form. Since two of the or either of the expressions or any of the one of the expression or both expressions give the same result that is generated by the valid database. These are the various operations that will be used. Now these are the examples of the transformations. We can illustrate the use of the equivalence rules. We see our university example with the relational schemas. This is the instructor, then ID, name, department name, salary, then teaches, ID, course ID, section ID, semester, year, then course ID, title, department name, credit. So in our example in section 13.1, the expression is this one: name, title, department name equals to music, instructor teaches, course ID, title, there is a course, that are transformed into the following expressions, which it translates or which is equivalent to the original relational algebra or relational expressions. Now this is also the query, that is the initial expression tree, that is the tree after the multiple transformation. So this is the initial phase, this is the after the multiple transformation. Then next is the join ordering, that is how to join the orders, or what are the various order in which we can join the expressions. So the good ordering of the join operations is important for reducing the size of a temporary result. So whatever the join operation that will be carried out, that will be very important for reducing the size of a temporary results. Hence, most query optimizers pays a lot of attention to the join order. As mentioned in the chapter 10 in the equivalent tools 6a, the natural join is associative. Therefore, all the relation R1, R2, R3 are the joined with each other. That is, R1 is joined with the R2, R2 is joined with the R3. Then what is the enumerators or enumeration of the equivalent expressions, that is how to enumerate the various content, that is the query optimizers uses the equivalence rules to be systematically generate the expression, that is how to use the expressions, what are the various methods to explain the or estimate the expressions. Next is estimating the statistics of the or statistics of statistic or statistics of the expression results. The cost of an operation depends on the size and the other statistics of the input. So it depends on the cost of the operation, that will depends on the size. So whatever the cost that will be incurred, that will be required, that depends on the size and the other statistics of the input. Given expression, that is the A is joined with the B, B is joined with the C, to eliminate the cost of joining A with the B and the C, and we need to estimate the statistics such as the size of the B and the join C. In this section, we first list some statistics about the database relations that are stored in the database system catalogs, and then show how to use these statistics to estimate the statistics on the relation on the result of the various relational expressions. One thing that will occur that is used in the estimation is not accurate. So whatever we estimate, that is a rough idea, not the accurate estimates. Your query is that can we enter them in the SQL database just as we enter the query statement, or they are just the conversion, that the machine conversion? No, we can simply just give the query and use the F5 key, or use the execution tool that will execute the phase. There is no need to first of all compile that is converted into the binary language. No, there is no requirement for compilation. There is no requirement of conversion into the binary language. So whatever the estimate that we'll use, whatever the plan out that will be used, that will be carried out in a variety of methods. So we are taking the query evaluation plan that has the lowest estimated execution cost, may therefore not actually the lower execution cost. However, the real world experience says if the estimates are not precise, the plan will be carried out to lower the estimation cost, and usually have a actual execution cost that are either the lower or the lowest execution cost, or the cost that is very close to the lowest execution cost. So whatever the close cost that will be used, that will use as the lowest execution cost. Yes, you can execute the query in the SQL also, no issues. The first one is the catalog information. So the database system catalog stores the following statistical information about the database relation. So in the catalog information, following information will be stored. That is how many number of tuples are in the relation R, how many blocks are containing the tuples of the relation R. That means how many tuples, how many rows, how many blocks, how many divisions, what is the size of a tuple of a relation R in the byte. That is what is the size of the row that will be used in the that will be expressed in the terms of the bytes. Then the blocking factors of the relation R, that is the number of bytes of the relation R that fits into one block. Then VAR, that is the number of distinct values that appears in the relation R for attribute A. That is a value that is same as size of the pi AR. And this is the tuple relation that will be used, that will be combined together. This is the BR, then there will be NR and the FR. Statistics about the indices such as the heights of the B plus tree indices and the number of leaf pages in the indices also maintained in the catalogs. So if we wish to maintain the accurate statistics, if we wish to maintain the accurate statistics, then every time a relation is modified or must be updated to update the statistics. That is, we have to update the statistics to update the relations. Therefore, update incurs a substantial amount of overhead. That is, there will be a overhead, there will be a cost that is used. But these relational algebra contain symbols we are not in our keyboard, so what we do input. So you are not taking the input over there. This is your question. So how to give the pi sign, right? So just do one thing, write the query in the MS Word, use the symbols in the MS Word, just copy the content from the MS Word and paste in the SQL language. So this is the formula that is used for the relation, that is the NR divided by FR. And the statistics about the indices such as the height of the B plus tree indices and the number of leaf nodes pages in the indices are also maintained in the catalog. So this is also defined in the catalog for maintaining the result. So if we wish to maintain the accurate statistics, then every time a relation is modified, we must also update the statistics. The statistical information, okay Larry, the statistical information noted here is simplified. The real world optimizer often maintain further statistical information to prove the efficiency of their cost estimation of the evaluation plan. And the most database uses the distribution of the value for each attribute as a histogram. That is, a histogram is a method in which the values are divided, or values are we can say the divided into multiple ranges, each with the range. The histogram estimates the number of tuple, that is shown in the histogram, that is shown in the bar, that is how much cost, how much the company requires, or how much the company uses for the histograms. Figure 13.4 6 explains the histogram for integer value that takes the number from the 1 to 25. This is the histograms. This one histogram 1 1 1 1. So from 1 to 5 there will be a person that is a 45, around 45. Then there will be a person that is a 37 35. That is, there will be a person that is 23 11 to 15. Then 16 to 20 there will be a 47 48. Then 21 to 25 there will be an expression that is 18. That is also defined in the terms of the histogram. That is the example of histogram. That is the range of the values that is given for attribute age of a limited person, that can be divided into 0 to 9, 10 to 19. This is the one of the example of the histogram also. So without such histogram information, an optimizer would have to assume that the distribution of values in uniform, that is each range has the same count. And there are various types of histogram that is used in the database system. For example, equi-width histogram that divides into equal sizes, and the equi-depth histogram that just at the boundaries of the ranges. Then next is the selection size estimation. That is, what is the selection size estimation that is used in the join operation. So this I'm not going to start right now. So let's finish the class over here only. In the next class, I am taking your next topic, that is this topic, that is selection size estimation. That is, what is the how to estimate the size, how to estimate the selection size. So let's stop the class over here only. And if there is any doubts, anything that you want, you can ask the doubts from me. So any clarification, anything. So we will meet tomorrow with this topic, that is selection size estimation. All right. So thanks a lot everyone for listening me. Bye bye everyone. Goodbye.